வணக்கம். இன்றைய வகுப்புல நாம இப்போ 3 சப்ஸ்ட்ரேட் கொடுத்திருக்காங்க. இந்த 3 சப்ஸ்ட்ரேட்ல இந்த கர்வ்டு ஆரோவை யூஸ் பண்ணி ஹெட்ரோலிட்டிக்கா உடைஞ்சதுன்னா என்ன கிடைக்கும் அப்படின்றது தான் இப்போ நாம் பார்க்குறோம். ஃபர்ஸ்ட் சப்ஸ்ட்ரேட் இது டைமெத்தில் தயோஈதர். இப்போ இந்த கர்வ்டு ஆரோ கிளீவேஜில் 2 விதமான கிளீவேஜ் இருக்குது. ஹோமோலிட்டிக் கிளீவேஜ், ஹெட்ரோலிட்டிக் கிளீவேஜ். ஒரு பாண்ட் இருக்கிறது 2 எலக்ட்ரான். அந்த 2 எலக்ட்ரானை ஒரு பக்கம் மட்டும் அந்த 2 எலக்ட்ரானும் ஒரு ஆட்டத்து பக்கம் மட்டும் போச்சுன்னா அது ஹெட்ரோலிட்டிக் கிளீவேஜ். இஃப் த 2 electrons are equally split up into either side, both sides, it is called homolytic cleavage. Due to the homolytic cleavage, free radical is formed, and here this is being more electronegative. The bonded electrons are shifted towards the sulfur. So as a result of heterolytic cleavage, this methyl ion gets positive charge and this gets a negative charge. In this case, the bonded electrons is shifted to the cyanide group, and here CH3 plus Cl minus. Because this cyanide group is an electron withdrawing group, so naturally there is during the heterolytic cleavage, the bonding electrons are shifted towards the cyanide. Therefore, cyanide gets minus charge and the methyl group gets positive charge. In this case, during the heterolytic cleavage, the bonded electrons are shifted towards the methyl group because this is electropositive metal. Electropositive metals do not attract the electrons. So CH3 minus and carbon gets positive charge. And let us switch over to the second question. And here are various species given, and you have to categorize which is electrophile and which is nucleophile. And of course, the electrophile is the one which is loving for electron, which has a thirst for electron. So all positively charged species are electrophile, and even the neutral molecule which is having shortage for octet can also act as an electrophile, and all the negatively charged species can act as a nucleophile. And of course, even there are certain neutral molecules which are rich in electron, which are having a lone pair of electrons already, can act as a nucleophile. So let us categorize the following species into electrophile, nucleophile, and let us take up the first case, HS minus, and electrophile we have to categorize into electrophile and nucleophile. So the first one is coming under nucleophile because it is already having a positive negative charge. Therefore, SH minus or HS minus is a nucleophile. And the second, and of course this is a nucleophile because it is rich in electrons, so it has the thirst for nucleus. And the second one, C2H5, ethoxide ion, it is already rich in negative, it is having a negative charge, it is rich in electron. So since it is rich in electron, it is a nucleophile. And the trimethylamine, the third one is, and this is a nucleophile. The trimethylamine is having a lone pair of electrons on the nitrogen atom.